Hello, everyone. Welcome to our webinar. We'll get started in just a couple minutes. All right, let's go ahead and get started. Welcome to our webinar, everyone. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to discuss how to construct quantitative research questions and hypotheses. So I'm going to go through the entire presentation first, and if you have questions, you can type those into the chat box or the question and answer box. My colleague Brittany will also be assisting with any questions you might have about the services that our company provides or scheduling links. And if you have any questions pertaining to the topic for today, I will be covering a question and answer session at the end of the webinar. We will be sending everyone a copy of the presentation itself, the PowerPoint, as well as a recording of the presentation. I'll start out by giving a brief overview of the services that our company Statistics Solutions provides. We'll then dive into the topic today in regards to constructing quantitative research questions, conclude with a summary and a question and answer session. So our company Statistics Solutions provides assistance with every part of the dissertation. So no matter where you are, if you're doing a quantitative or qualitative study, if you're at topic development, or maybe you're stuck somewhere in the middle with your literature review or developing research questions, figuring out what types of analyses you need to run, we can provide assistance in those areas. So starting with topic development, going through the proposal chapters, IRB forms, data entry templates. We can host your survey for you on our own SurveyMonkey company account. And we have literature review specialists as well as quantitative and qualitative specialists. So the methodologist can help you with the methodology, trying to determine what research design you need to use, what is the minimum sample size you need to target. Maybe you need to run a power analysis. And then once you've collected your data, we can help crunch those numbers using SPSS or Intellectus Statistics, which is our company software, which I'll provide a brief demonstration of our software at the end of the webinar. And then we also help with the discussion chapter, concluding your dissertation, PowerPoint proposal, and final defenses, as well as taking your dissertation and condensing it for a journal publication. So if you have any questions, I know Brittany has included some links in the chat box, but you can also give us a call here at 727-442-4290. On this slide, I have a list of the past webinars we've conducted. So we have a list of all the recordings so you can watch. And we've covered a variety of topics for all chapters of the dissertation. And there's also a link here for upcoming webinars we will be conducting in the future. So for today's topic, we're focusing on quantitative research questions. Before you even get to this step, oh, I just realized the screen is not sharing. I apologize for that. Okay, let me just back up a couple slides. So on this slide, you can see all the different components that we help with at our company, and we have the phone number at the bottom. On this slide, we have a list of the past and future webinars. And this is where I was right here. So it's important to lay the foundation for what is the difference between quantitative and qualitative research. Quantitative research involves collecting data numerically. So there need to be a finite number of responses or a finite number of options for people to respond. And it can be numeric, it can be categorical, or measured in units of measurement. So usually if you're using a Likert scale survey, something like strongly agree to strongly disagree, you'll end up going in a quantitative direction. And usually with quantitative research, there are hypotheses that accompany your research questions. So hypotheses are, in general, it's what you're trying to prove. Do you have a theory or you have a hypothesis in mind that you can prove statistically? This is in contrast to qualitative research, in which you have open-ended responses. Maybe you've conducted an interview to determine the underlying perceptions of your sample. So when you look at open-ended responses or an interview format, you aren't constrained to a Likert scale survey or multiple choice. You have open-ended responses that could be a paragraph long, in which you have to uncover common themes in which your participants are providing. The quantitative includes numbers and can be proven statistically, and qualitative is usually open-ended. It involved exploring the underlying phenomenon of a topic. So once you've determined if you're going in the quantitative or qualitative direction, you want to begin developing your research problem. So you need to identify a gap in the literature. So usually you want to find a topic that has not been conducted before. You want something unique that your study brings to the table. So many people jump right into developing research questions, but it's important to first lay the foundation. What is the gap in the literature? What is your topic adding that no other paper has contributed before? After identifying the research problem and the gap in the literature, you then want to identify a list of all the key variables in your study. So are these variables numerically measurable? Can you collect the data with a self-report survey, or do you need to use archival secondary data? So quantitative research branches into self-report surveys, usually a Likert scale survey, or you can use data that already exists, something like hospital records. Okay, so on this slide, we have the 4 most common quantitative designs. We have descriptive exploratory designs, we have correlational designs, then we have more of the causal comparative experimental designs, and then finally we have longitudinal designs. These are the 4 most common procedures I see used in dissertations today. So I would recommend trying to pinpoint a topic that goes into one of these research designs. The first design we have here is exploratory. So a descriptive exploratory design is kind of a rare case for statistics. You aren't necessarily trying to prove or disprove hypotheses. It's more looking to examine trends in your sample. So what are the participants' underlying, or what is their overarching perception of a topic? That's usually collected with a survey. So I have a couple sample research questions here. What are the trends in job satisfaction among teaching faculty? Or what is the predominant leadership style used among managers in a workplace? So as you notice here, we aren't correlating variables. We're not looking at differences between groups. It's exploring for trends in the sample. So just identifying means, standard deviations, frequencies, percentages. Usually you can use histograms or bar charts to address questions like these. The caveat to this is that some committees may consider this to be too simplistic of an approach for a dissertation. Maybe for a master's thesis, this would be approved. But I have worked on dissertations that it's okay to use descriptive exploratory designs. It really depends on the luck of the draw and if your committee is on board. If you're doing a mixed method study in which you're doing quantitative and qualitative, then you want to try and make the quantitative and qualitative as simplistic as possible because you have a lot of moving parts if you're doing mixed methods. So I would try to do a descriptive exploratory design for the quantitative side if you are doing mixed methods. So a correlational design is kind of an overarching concept. It's an umbrella concept in the idea that it encompasses both correlational analyses and regression analyses. So correlational analyses are looking at the association between variables of interest. You don't necessarily need to have an independent or dependent variable. It's looking to see as one variable increases in value, does the second variable increase or decrease? And that relationship be examined vice versa as well. So that's why you don't necessarily need independent and dependent variables when doing correlational tests. When you're doing a regression analysis, which I'll describe on the next slide, you do have independent and dependent variables. Those are usually called predictor variables and criterion variables. So it depends what analyses you're trying to run, but in general, correlational research is looking at the association between variables. So we have two sample questions here. Is there a significant relationship between age and self-efficacy? Is there a significant association between education and job position? So compare these research questions to the previous slide. This was the descriptive exploratory design. And as you can see, we're just looking at trends. And these two research questions, we're not correlating it to another variable. Whereas in a correlational design, you have an X and a Y. You have two variables of interest. So underneath this family of correlational analyses, these are the three most common procedures I see used statistically. So we have Pearson correlations, which are used when you're looking at the relationship between two continuous variables. We have Spearman correlations, which are used when you're looking at the association between two variables, but at least one of those variables is an ordinal measurement. So that could be a multiple choice item. It could be a Likert scale item. It could be something like education level, which has a natural hierarchy to it. You won't see a fill in the blank for education where someone puts, I have 11 years of education. You have categories. You have high school, associates, bachelor's, master's, doctorate. So if education is one of your variables of interest, then you might want to consider doing a Spearman correlation. And then we have chi-square tests of independence, which are used when you have two categorical variables. Okay, so something like ethnicity and job position or gender. Those are categorical variables that don't have a hierarchy to them. You have discrete groups, no predominant group, gender, male, female, ethnicity, white, male, black, Hispanic. If you're testing the relationship between two categories, then you do a chi-square test. On this slide, I have an example of hypotheses that accompany the research questions I listed before. So we have a null hypothesis, which is the top one here. Usually it has a 0 accompanying the hypothesis, and you have an alternative hypothesis. Usually in statistics, everything revolves around the null hypothesis. You either reject the statement if you do find a significant relationship, or you fail to reject your null hypothesis. So it will always be a null saying there's not a significant relationship, and then an alternative saying there is a significant relationship. So we've discussed the correlational analyses under the correlational design. There are, as I mentioned before, there are also predictive analyses. So when you do a predictive relationship, you have independent variables and you have dependent variables. These are usually called a predictor and criterion, respectively. As you can see here, we have 3 sample research questions. The key word in here, or key words, I should say, are significant predictive relationship. Once you see those 3 words, we can assume that we're looking at a predictive association. So we need to use regression models. So as we can see down here, the 4 most common procedures for regressions are linear regressions, which are used when you have a continuous dependent variable. So something like GPA or age, anything that's numeric that falls on an interval, that's when you do a linear regression. You can see there are 4 types of regressions here, and the type of regression model that you use is 100% dependent on how your outcome or dependent variables measured. So we can see with this first one, we have a continuous dependent variable. We use a linear regression. If we have a binary outcome, something like passing and failing of an exam, then we can do a binary logistic regression. Then we have a multinomial logistic regression, which is having a categorical variable with more than 2 groups. So if you're trying to predict ethnicity, for example, white, black, Asian, Hispanic, something like that, then you can do a multinomial logistic regression. And an ordinal logistic regression is used when your outcome variable is ordinal. So if your outcome is a Likert scale question, strongly agree down to strongly disagree, then you can use an ordinal logistic regression. Also, something like education level could be used as the outcome. Here again, we have the sample hypotheses. So again, I just took the research question, turned it into a statement, and then included there is not and there is for the null and alternative hypotheses. The third research design is experimental. So there are many different names for this, and it depends specifically what you're trying to do. But we have experimental, quasi-experimental, and causal comparative designs. Now, the difference between these, if you're doing an experimental design, usually you have randomly collected data. That's important, that your data is randomly collected. You've assigned people to treatment and control groups, and then you're doing a pre-test, intervention, and a post-test. That's usually how an experimental design happens. So quasi-experimental is when the quasi-experimental and causal comparative kind of go hand in hand, but when you don't have random assignment or random collection of data, you have purposeful sampling. So you've collected participants and you are assigning them to treatment and control groups, but there's no random assignment happening. That's usually when you go with a quasi-experimental or causal comparative designs. Causal comparative can also happen if the groups you're trying to compare are predetermined, like something like gender is male and female, or ethnicity. Those are predetermined characteristics. You are not assigning those characteristics as a researcher. It's predetermined. So that's when you do, again, quasi-experimental or causal comparative. So the idea behind these is that you're looking for differences in a variable between groups. Okay, so here we have sample research questions. We have, for instance, is there a significant difference in job satisfaction between the treatment and control groups? Or is there a significant difference in self-efficacy based on race? Each of these research questions ties to a specific analysis below, right here. So sample research question 1, we're looking at a difference in a variable between two groups, treatment and control. This is when you would use an independent sample t-test. It's used to test for differences in a continuous variable between two groups. And ANOVA, which is short for analysis of variance, is used when you're looking at differences in a continuous variable between 3 or more groups. So it's taking that idea of a t-test and just adding an extra group. A MANOVA, or a multivariate analysis of variance, is used when you have multiple dependent variables. So sample question 3 right here, are there differences in burnout? So emotional exhaustion, depersonalization, and personal accomplishment. Those are our 3 dependent variables, and race is our independent variable. So because we have multiple dependent variables, you can use a MANOVA. And then the final example is an ANCOVA or a MANCOVA. The C stands for covariance. So it's used when you're looking at differences in a variable or multiple variables between groups, but you are controlling for an additional factor. That is sample question 4 right here. Are there differences in these 3 factors between race while controlling for job satisfaction? So that's when you do an ANCOVA or a MANCOVA. Now here we have the sample hypotheses for the research questions. And the final design type is a longitudinal design. So this is used when you're looking at differences in a variable that's collected at multiple points in time. There is a crossover here with experimental designs. So a true experimental design is actually longitudinal. You have treatment and control groups that are randomly assigned, and you're looking at differences over time. So perhaps you collect a baseline or a pre-test measurement, you administer your intervention, and then you measure the same variables at post-test to see if there's a difference. So this is when you run a longitudinal design. It's really important that you match the same people at pre-test to post-test. So whether you use an identifying number, usually you don't want to use names. You want to keep everything de-identified. So assigning people a random name or a number, maybe they pick cards from a hat to figure out what is their number or ID. You have to have the data match between pre and post test to do a longitudinal design. So here are some sample questions. Is there a significant difference in knowledge between pre-test and post-test of an educational intervention? Is there a significant difference in knowledge between baseline, post-test, and follow-up? So notice the difference between RQ1 and RQ2. They're very similar, but we've added an extra time frame. So not just pre-test and post-test, but there's a follow-up that's done in the future. And then sample question 3, is there a difference in knowledge over time and between groups? Maybe the most complicated example. So for the first question, you can run a paired sample t-test because you only have 2 points in time. Once you add a third time point, we can't just run a t-test. We need to run what's called a repeated measures ANOVA. So that's testing for differences in a variable over 3 or more points in time. And then this final question, sample question 3, is looking at differences in a variable over time and between groups simultaneously. So this final one is most likely what you will use if you're doing a true experimental design. So we can see the sample questions here and the sample hypotheses. It's really the third one that is, the third one can trip people up because there are a lot of moving parts. So for instance, are there differences in knowledge over time and between groups? So say we're just doing a pre-test and post-test, and we have a treatment and control group. So we have 3 things to look at. We need to see, are there differences over time, regardless of what group the people are in? Are there differences between the groups, regardless of what time the data is being collected? So essentially, are there differences between treatment and control? And then the third is probably the most important. This is called the interaction effect, where you want to identify if there are differences over time and between groups. So you have pre-test treatment, post-test treatment, pre-test control, and post-test control. So you have 4 moving parts there, and we want to see, are there differences collectively by group and over time? Okay, so in summary, before even diving into your research questions, you first want to pinpoint your problem statement, your purpose statement, and identify a gap in the literature. So there needs to be something that is making your study unique. Kind of a way to get around this is to localize your study. So maybe something's been done in the past and you want to replicate study that has been done. But if you centralize the location in which that study is being conducted, that can make it unique. So if you pick a certain city or a certain business, you can make the study unique by localizing the problem. Then you want to determine if the data that you're collecting requires a survey, archival data, or it needs to be conducted through interviews. Again, quantitative is going to have closed-ended responses. Everything's going to be numerically measurable, whereas qualitative requires an underlying perception of a participant. So you need to conduct interviews to understand those perceptions. Then you want to identify your variables of interest. So you need to know, are your variables going to be nominal, ordinal, or interval? And you need to pinpoint whether you're going to use a previously validated survey or if you're going to collect data through an archive. So something like hospital records, you probably need permission to access that data, but it's an archival data set that exists, and it may have all the variables of interest that you need. When you're using a survey, it's really important to keep in mind that using a previously validated survey will save you months in the process, maybe even years. When you develop your own survey, you have to pilot test it. You have to prove that it is reliable and valid. And that can be a strenuous process. So I would highly recommend using a previously validated instrument or finding archival data online. Then you can pinpoint your research design. So I mentioned the four primary options: exploratory, correlational, which branches out into correlational analyses or predictive analyses. And then we have the experimental family, which is looking at differences between groups. And we have longitudinal, which is collecting data over a time period, multiple times. Then you can develop your research questions and the hypotheses, which usually when you follow a certain research design, there is a particular way to phrase your research questions. And those are all in the presentation here. You know, like when you're doing experimental, the key word is significant difference. If you're doing predictive, then you want to have significant predictive relationship. If you're doing exploratory, then you just look at trends. So what are the trends in a particular variable? And then once you're there, you can determine what analyses are best to address those research questions. Okay, so just to reiterate, our company does help with all parts of the dissertation. So if you've hit a roadblock, please give us a call at 727-442-4290, or you can email us at info@statisticsolutions.com. I'll now open the webinar for questions if we have any, so you can type those into the chat box. And we will be sending everybody a copy of the presentation. We have a question that says, for a quantitative study, for example, descriptive cross-sectional study, must you have hypotheses, or can you just use research questions? Descriptive, then you don't necessarily need to have hypotheses. And this is really something that comes down to your school and the template for your methodology. Some schools require hypotheses, and you'll have to include something there in terms of what you're anticipating the findings might show. But in general, exploratory descriptive designs, you're not necessarily hypothesizing anything. That's the whole point. You're trying to see what are the trends in the participants, what are their perceptions in general. So you don't necessarily need hypotheses. You can just get away with having research questions alone. Okay, do we have any other questions? Just to show the upcoming webinars that we will be doing. This is our company website. And if you go to the webinar tab right here, you can see upcoming free webinars and the archive library. So the archive library has recordings of all the previous webinars we've done. So you can see we've touched on the introduction, so chapter 1, your literature review, both quantitative and qualitative methodologies, how to present both quantitative and qualitative results. And then for the upcoming, it looks like we have 2 more this month. We have one tomorrow and one Friday. My colleague David will be running both of these webinars. So mastering your quantitative methodology and confidently presenting your quantitative results. So check those out if you've hit a roadblock and just need some assistance. All right, we have a question from Lisa. Can quantitative studies be descriptive studies as well? Will be correct to write descriptive cross-sectional. Yeah, I've seen that exact description used, descriptive cross-sectional study. I think that's completely appropriate. I would always try to go in that route. When you're writing a dissertation, time is of the essence. You don't want to keep paying tuition, obviously. So try a simplistic approach with your committee. See if they are on board with a descriptive cross-sectional study or an exploratory study. And if they are on board, that's going to expedite the process for you. And if they're not, then try to tweak it, try to make it correlational, maybe add an additional variable into the paper. That way you can correlate one variable to another. Try to start out simplistic, and then if it doesn't work, add additional variables to your study. We have a question. If your data violates the assumptions for Pearson's correlation, what are your options? So actually, I meant to show our company's software here. So Intellectus. This is our company's software, Intellectus Statistics, which is used for a variety of things. It can be used to determine what analyses you need to run. So we have a decision tree here, and you can see for this example here, if you're trying to run and explore relationships, we can start the decision tree right here. And if everything is scale, it goes down the decision tree, and this is most likely a Pearson correlation. However, if we go into data analysis plans and Pearson correlation, you can see the write-up for this here. Usually the option, if normality is not supported or linearity, one of the assumptions is not met, you want to run a Spearman correlation as a backup. Okay, so a Spearman correlation is the non-parametric alternative to a Pearson. And it's usually used when the assumptions are not met. Okay, so in Intellectus, you can see I showed the decision tree. We have data analysis plans, which would go in your methodology. So we have the sample questions here. What is the relationship between variable 1 and 2, sample hypotheses, and a description and definition of what the analysis is, as well as a verification of assumptions. We also have power analyses in here. So if you're doing a correlation, we can figure out what is the minimum sample that we should target. So I clicked Pearson correlation, and we can see based on what effect size we're using, large, medium, or small, there is a different sample size requirement. Usually if the literature does not indicate what effect size to use, you just go with a medium effect size. So for this example, a Pearson correlation requires 82 participants at a minimum. Do you advise reformatting the data? I try to avoid transforming data. I'm not sure if that's what you're referring to. But for example, I have a data set here. You can transform the data into different formats. So we have logarithmic, reciprocal, cubic functions. I try to avoid doing that because it changes the interpretation of your data once you are actually analyzing the data. And so once you run your correlation, everything's relative to a logarithmic transformation, which I don't like to do. I like to keep everything level in the raw format of the data. So usually I would just say run a Spearman correlation. Maybe present the Pearson correlation, present how the assumptions came out, maybe normality was violated. And then you can still present the Pearson correlation, but also present the Spearman correlation as a backup. I think that's a good way to go about it. because then your committee will tell you, every committee is different. They all have preferences. Some committees will want you to present both. Some committees will say, no, because the assumptions were not met, we're just going to present the Spearman correlation instead of the Pearson. Okay, but long-winded answer to answer your question. No, I don't advise transforming or reformatting the data. I would just present the non-parametric Spearman. Yeah, you're welcome. Do you have any other questions? Yeah, so also an intellectus, this is where you can crunch your numbers. So we double checked and verified everything with SPSS. So you can clean your data in intellectus. You can change variables from scale to nominal or ordinal. You can transform, as I just indicated, remove for outliers, replace missing data with imputation, reverse code. Then we have plots in here that you can generate, so bar plots or pie charts and histograms. And then you can jump to the analyses. So you can actually run the analyses for you, and it is presented in an APA write-up, an APA formatted tables. Let me just run an example of a correlation for you here. So I'll do a correlation between these two variables, teacher concerns in the workplace and self-efficacy. So you can see here, it's going to verify the assumptions of a correlation. It's going to check for linearity. And then it's going to run the Pearson correlation. So you can see that there is a significant relationship. And this is our correlation coefficient, which is negative, indicating that as teacher concerns increases, self-efficacy tends to decrease. And so we have a series of different tests you can run, t-tests, ANOVAs, regressions, even non-parametrics over here. For Spearman correlation, does meeting or not meeting the assumptions make a difference? It depends what assumptions you're checking. The key assumption for a Spearman correlation is having a monotonic relationship. So as I go over here, you can see right here, they talk about having a monotonic association. So you need to clearly see a positive or negative trend in a scatter plot. And if that is not supported, there isn't really an alternative. You have to interpret your results with a level of caution at that point. If the assumptions are not met, you proceed, but interpret with caution. I'm going to put the link for Intellectus. I do see we have a question about Intellectus. I'm going to put the website URL in the chat box so you can check that out. I actually don't handle the cost and payments. I just work with clients one-on-one. So you can check out the website and you can reach out for more information about that. All right, do we have any other questions? Like Brittany added some information in the chat box. So Intellectus starts at $59 a month, which is a great deal if you're comparing it to SAS or SPSS, which are much more expensive. And they don't give you an APA write-up in either of those softwares. So you're going to save time and money by using Intellectus. All right, any other questions about the topic for today or Intellectus? Hey, Anna, I'm going to defer to Brittany on the annual subscription question. I'm actually not positive. And then we have a question from Sarah. Does that matter when using SPSS versus Intellectus? I'm not sure I understand your question. Does what matter specifically? The thing is, the statistics are going to match exactly. In Intellectus, we have double-checked every analysis in SPSS and cross-referenced it with Intellectus. So some committees might have a preference. You know, they might be experts in using SPSS, so they prefer that you use that software. And we do have specialists at our company that use SPSS exclusively. So both are options. I would say use Intellectus because it's going to save you time. You won't have to worry about the interpretation of the findings. It's going to interpret it for you and put it in APA format. Yeah. So it looks like we don't have an annual option for Intellectus. The options are strictly monthly, but we do offer a free trial as well. And if you're doing a dissertation, probably don't need Intellectus for more than 2 to 3 months. If you're doing studies outside of the dissertation, then you might need it for a longer time period, but usually you can knock out the results chapter in just a couple months. Okay, do we have any final questions? All right, well, thanks for joining, everyone. We are doing 2 webinars for the remainder of this week, one tomorrow at 11 a.m. Eastern, and then one on Friday at 11 a.m. Eastern, both pertaining to quantitative studies. So I would highly recommend joining those if you're in the methodology chapter or if you are beginning your results chapter. But yeah, thanks for joining. Let us know if you have any questions. And we will be sending everyone a copy of the webinar and the PowerPoint. Have a great evening.